Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math basic course. And as always, it is an honor and a privilege to be serving you today, as it is every day here in my virtual classroom. Step on inside as we jump in section 3.3 in the Big Ideas Math Integrated Math 3 textbook on polynomial division. So we're going to do using two things, long division and synthetic division. I love synthetic division, but we can only use it in very specific scenarios. We do have to know long division. Hopefully you know some long division from actual numbers. It wouldn't hurt if I actually revisited what it looks like. It doesn't look like the book's actually doing it. They're going straight into polynomials, which is fine. But I want to make sure you know what it looks like to do long division as a whole, what it means to have a remainder, and how I can even use the use numbers to make them look like the polynomial version of them. Yeah, I think I'm going to do that. So that'll be a part of the lecture portion, meaning I'm going to make some problems for myself in a way, just to get some tie-ins on what they're going to do. So if you'd like to follow along, jump to the description section down below and download the PDF down there and follow along with the timestamps where you can click on if you want to start the problem set and skip my lecture, go ahead. Otherwise, we're going straight to the lecture portion. So we're going to use long division to divide polynomials by other polynomials. Polynomials being like x squared plus, whatever, or x to the fourth minus, like those. Synthetic division, we use that to divide polynomials by binomials of the form x minus k. Now they're being very specific with this, and I will as well. Synthetic division only very specifically works in, it's not like true division, if that makes sense. It probably doesn't to you just yet, but in synthetic division, it only works in this form. It only works in this form. Just take my word for it. I'll probably show you how it does or why it does. And use what's called the remainder theorem. We'll dive into that in a moment. Now, in order for this thing to work best, let's do a long division problem with just numbers and make sure that we know what we're talking about with what long division is. Or maybe what my visual style is, right? Not everyone's going to have the same visual style of long division. You might not have the same as me. I might not have the same as the book. Things like that. But I'm going to stick to my style. Stubbornly, I'm going to stick to my style. Let's take a thousands divided by tens. Let's do like, not too big. Let's do 1647 divided by... Let's do an even number, 12. I want to make sure I do get a remainder. So we'll do it like that. 1647 divided by 12. Okay. 12 goes into 16 one time. I'm not getting too deep into the teaching of this. I'm just saying things out loud, see if it makes sense. And 12 times 1 is 12. You do 16 minus 12 and you get 4. Bring down the 4 and the 7. And I now want to see how many times 12 can go into one of these numbers most. 12 can go into 44. 12 can go into 44 3 times, because 12 times 3 is 36. And 44 minus 36 is 8. Bring down the 7. 12 goes into not 8, but 87 7 times. 12 times 87 is 84. 87 divided by 84 is 3. 12 can't go into 3, so 3 ends up being the remainder. So this becomes 137, remainder 3. Now, on a visual style with me, the two things I might do differently than you would do in this scenario, and I hope that this made sense in what I said, but you might say, I do it differently. What you do differently might just be visual only, though, right? It's not in how you actually do the division stuff itself. We checked, see how many times 12 goes into 16, write the number there, all that stuff, great. But notice a couple things I didn't do. I said 16 minus 12. I didn't show 16 minus 12, right? I don't actually write the subtraction. I won't. It's part of what I just do. So I'm not going to show the subtraction. The other thing is I keep bringing this 12 down. I need to make sure I'm comparing to whatever specific number I'm comparing to, like that. So just kind of keep that in mind. I don't think there's a problem with that, but in case you don't do it, you're like, what are you doing? I'm doing that division each time as I bring more numbers up and write them down. Now, the remainder of 3 is something where, cool, this is an answer, but it's not the form of the answer that polynomials are going to actually be presenting. So, now that we did that problem, let's start reading into what they have. Long division of polynomials. When you divide a polynomial, f of x, like say this thing, by a non-zero polynomial divisor, like this. By the way, divisor, this is called divisor, this is called dividend. The result is a quotient. You get a quotient polynomial and a remainder polynomial. But here's how you can write the result of it. Now, I'll do the same thing with this one right here. When we take 1647 and divide it by 12, the result is the quotient, which for us is 137, that's the whole, plus the remainder. Now the remainder is still dividing by the divisor. So it's not just plus 3. It's plus 3/12, right? It's the part that couldn't divide out of that whole, so it's written as a fraction, right? That would be the result of this. Oh, this one can reduce as a fraction as well. I don't know if the ones we do here will be able to reduce as fractions. I don't anticipate that, or we're not probably going to look for it. So this becomes 1/4, okay? And then this would actually equal 137 and 1/4 if we wrote this as like a whole number like that. We don't do that with polynomials there because they don't combine in that way. So they'll stay separate as the plus thing. But that's the true result of this number. Like if I type 1647 over 12 in my calculator, I'm going to get 137.25, right? But that's how the remainder works, guys. The remainder is added to your thing, provided that it's being divided by your divisor. And that's how our polynomial long division is going to go. Now, will all of our answers have a remainder, a non-zero remainder? I don't know. I haven't done their problems yet. I've done worksheets of these things before. I think on those worksheets, I start by showing ones with zero remainder, just to make sure you know that you're doing it right. But in this case, we might have all remainders. I have no idea. Because they want to talk about remainder theorem, remainders right here. You can expect probably mostly remainders. Anyway, they're going to jump straight into the long division thing right here. I feel like, sorry, I'm at pause in how I want to do my own video. I want to show you how polynomial long division appears by using numbers again. I'll use these exact same numbers, but I'm going to give it a long division flair, a polynomial long division flair to it. I don't know what I even want to do with these numbers. I just want to make sure that we know we got the same answer. So 1647 divided by 12, right? 1647 divided by 12. Here's what long division is going to look like. Remember that you can't combine unlike terms. So let's pretend like these were non-like terms that added together based on the digit that it is, whether it's the thousands place or the hundreds place or tens place or ones place. Let's write 1647 as 1000 plus 600 plus 40 plus 7. Or you know what? I'll provide an extra flair to it. How else can I make 47? I can do like 50 minus 3. Plus 50 minus 3. And if you're following along with this, you don't have to write anything down or anything like that. I just want to give you the understanding of how this is going to work if this is your first time seeing it, because this can carry the same rule. Now that we've seen this answer of 137 with remainder of 3, I'm going to show you I can get that same answer here with this. So here's how it's going to kind of look. Here are the constructs of it. We want to take the most significant digit, in this case the tens digit and the thousands digit. Basically, in our case, is the leading term. We want to see how many times 10 can go into 1,000. 10 goes into 1,000 100 times. What you're now going to do is you're going to multiply 10 by 100 to get 1,000, and you're going to multiply 2 by 100 to get 200. And you're going to subtract this result, but only combine like terms, meaning only subtract thousands with thousands, hundreds with hundreds, things like that. Now, 1,000 minus 1,000 is 0. Those cancels out. 600 minus 200 is 400. Down comes the 50 and the minus 3. Now, I want to once again remind you that when I do the subtraction, I don't actually write minus. When these canceled, it was through subtraction. You're like, 600 plus 200 is 800, Mr. Robinson. I'm subtracting them. I'm subtracting 600 minus 200. I will not write it as subtraction. I'm going to be stubborn on that, guys. I'm not going to write subtraction. In fact, I'm looking at the book right now. I didn't realize this until the book doesn't write subtraction either. I don't want to jump into this problem, but notice how these, 3 minus 6 is negative 3. They too don't write subtraction. I win. So they agree. There we go. All right, we continue forward. We do this until 10 can't go into anything any longer, basically until we run out, until we get down to the ones digit. So now we check and see how many times 10, the leading term, goes into 400, the leading term. 10 goes into 400 40 times. We're going to add 40 to this. Notice how this is like polynomials, because I'm not combining, I'll combine them in the end, but I'm keeping them separate for now. I'm going to multiply 10 by 40, 2 by 40, write them down here and subtract the result. 10 times 40 is 400. 2 times 40 is 80. Subtracting the result. 400 minus 400 is 0. 50 minus 80 is negative 30. Bring this negative 3 down, and let's go again. I want to check how many times can 10 go into negative 30. 10 can go into negative 30 negative 3 times. 10 times negative 3 is negative 30. 2 times negative 3 is negative 6. And we're going to subtract this result. Negative 30 minus negative 30 is the same as negative 30 plus 30, which is 0. Negative 3 minus negative 6 is the same as negative 3 plus 6, which is positive 3. Now, if I wrote 10 plus 2 right here, keep in mind, I try and see how many times 10 can go into 3. It can't. 10 cannot go into 3. This is where we would stop. 10 is a larger digit, right? It's a 2-digit number. 10 is a larger digit number than 3 is. A 2-digit number cannot go into a 3-digit number. So this is where we would stop. We'd get that remainder of 3. Now, what's the result? The result is 100 plus 40 minus 3. 100 plus 40 is 140. 140 minus 3 is 137. And the remainder of 3 goes here, divided by the 10 plus 2 divisor right there. So the result's the same. Now, why did I do all this? Why am I 11 minutes in and not having done any of their examples yet? Because I want you to understand the visual style of what they do, and I want to do it in a way that can be agreed upon with this. Now, would I use long division with numbers this way? No, I would do it the way that you saw right here. I'm giving you the tie-in as to how I use numbers, the ones that give me the same answer as the number we had, into how long division has to work with polynomials, because polynomials can't combine unlike terms. Right? So x squareds cannot combine with x's. X's cannot combine with constants. They have to stay separate. So when we wrote this answer like this, polynomials are going to have to stay separate. And they do this thing. They do the leading terms thing in division, and they do the cancellation portion that you saw right here. By the way, I want to make mention, if these terms do not cancel with what you do, something went wrong. Something went wrong, right? The way that these ones work is they're going to cancel because the way that these terms are broken up. And same is going to be true for here. So I probably skipped some things that they stated. Let's go ahead and take a look at what they stated because I only got to this part. The degree of the remainder must be less than the degree of the divisor. Yes. So when you take, for instance, this 3 is a singles, is a 1-digit number, and the 12 is a 2-digit number. In this, well, 3 is less than 12 in this case. For what we do on these ones, though, this needs to be smaller than that. When you see a remainder of this answer right here, that is degree 1, this is degree 2. It needs to be smaller. It can't be degree 2, otherwise it would have been able to divide. We would be able to write division. When the remainder is 0, okay, we'll probably get some 0. The divisor divides evenly into the dividend. That means it's a perfect division, right? Like, 48 divided by 12 is 4 with a remainder of 0. Also, the degree of the divisor is less than or equal to the degree of the dividend f of x. Yeah, if, like the 10, this is a 2-digit number and a 4-digit number. Well, I should stop talking about their numbers, but, when they do divide this by this, notice that this needs to be, degree 4 needs to be greater than or equal to degree 2. Otherwise, your answer is just a remainder already. There's no division to be had. One way to divide polynomials is called polynomial long division, and they're showing you the scenario. Let's tie it into what we did here. Write the polynomial division in the same format you use when dividing numbers, I guess long division. Include a 0 as the coefficient of x squared in the dividend. So what they're doing here is, here's your dividend. Notice it's missing an x squared term. They're including a placeholder that is x squared. I recommend you do this as well. I'll try and do the same. If not, I'm going to just leave space there. But I do recommend that you write it. The idea is you still need to combine like terms. And x squareds want to combine with other x squareds. Some will show up even if you started with a 0. And write it in standard form in descending order of degree. So to the 4th power, 3rd power, 2nd power, 1st power, 0 power. Right? Here's dividend and divisor, and let's see what they say. At each stage, divide the term with the highest power, leading term, in what is left of the dividend by the first term of the divisor, leading term. So we're going to do this divided by this. This gives the next term of the quotient. So we're going to see how many times in this example 2x to the 4th, how many times x squared goes into 2x to the 4th, right? This is 1x squared, remember. 1 goes into 2 times. X squared goes into x to the 4th, x squared times, so it's 2x squared. Now, we're going to confirm this result by doing what? We're going to multiply x squared by 2x squared, and we get 2x to the 4th. We're going to multiply 3x by 2x squared to get 6x cubed. We're going to multiply 2 by 2x squared to get 4x squared. Remember, that's the same thing I did right here. I did 10 times 100. I did 2 times 100. 10 times 100 was 1,000. 2 times 100 is 200. Oh, how do we confirm we did this thing right, by the way? X squared times 2x squared is 2x to the fourth, right? These should be able to subtract and cancel. If these don't cancel, something went wrong. We want to say exactly how many times this goes into this. We're going to write that number there, and they should go away. We're going to reduce our results will be 1 degree smaller than it was before. We were degree 4, now we're degree 3. Now we subtract the rest of these as we go along. 3x cubed minus 6x cubed is negative 3x cubed. 0x squared minus 4x squared is negative 4x squared. Mr. Robinson, that says a plus. That says a plus. Remember, we are subtracting the result. Even they, where's theirs? Subtract. Even they don't actually literally write subtraction and change the signs. I'm not saying you have to or not. I'm saying I don't. And when I say it out loud, I'm going to make sure to follow along with that. Now, this is where most mistakes are made if you turn this into 9x cubed or something like that. So be careful. But just want to make sure you know that. 5x minus 0 is 5x. Bring it down. Negative 1. I would technically be bringing this one down as well. I don't want to forget it or anything, so I'd bring that one down. Anyway, we're going to check and see how many times, and I'm going to write this as extra fluff because this is what I'm going to be doing. How many times does x squared go into negative 3x cubed? X squared goes in negative 3x cubed, negative 3x times. So now we do x squared times negative 3x, which is negative 3x cubed. Understand they should cancel through subtraction. 3x times negative 3x is negative 9x squared. 2 times negative 3x is negative 6x. We're going to subtract the results. These ones will cancel. Now be careful here. Negative 4x squared, this is minus negative 9x squared. So negative 4x squared plus 9x squared is 5x squared. 5x minus negative 6x is 5x plus 6x, which is 11x. And the negative 1 isn't combining with anything, so bring it down. So that's where it got brought down for them at the end. Now we keep going as long as the degree of the divisor is less than or equal to the degree of the leading term of the dividend, which it still is. X squared can go into 5x squared 5 times. Because x squared times 5 is 5x squared. Those will cancel through subtraction. 3x times 5 is 15x. 2 times 5 is 10. We're going to subtract the results. 5x squared minus 5x squared is 0. 11x minus 15x is negative 4x. And negative 1 minus 10 is negative 11. Now, why did they write this as the remainder? Because x squared cannot go into negative 4x because this is a larger degree than this. This is now, by all intents and purposes, a smaller number, just like 3 was less than 12. 3 can't go into 12 any number of times, that kind of thing, right? So that's the final result there, where we do have this quotient up top, right? These numbers were here for a reason. This is your quotient of your answer. The remainder is a big part of the answer, right? It's a fraction portion, I should say, but it's part of the answer. It's not that this is the whole part. So when they divided this by this, their result is what? The quotient plus the remainder divided by the original divisor. Here's that divisor, x squared plus 3x plus 2. This couldn't divide out, so this stays as a part of it. It's funky looking, it's there, but it does work. Now it's just our first example. We're already 18 minutes in. This is going to be kind of a longer thing. I really want to go for their visual style with that. All right, you can check the results of a division problem by multiplying the quotient by the divisor and adding the remainder. The result should be the dividend. A lot of that kind of sounds funky, but let's take a look at what they had. Here's the quotient. They're multiplying by that divisor, and they do their whole distribution stuff. I'm not going to get into it. But notice that the remainder is added afterward. Now, why does this work? Well, let's start with the number ones that we had here. 137. 137 plus 3 over 12 was the result of what division? 1647 divided by 12. So 1647 divided by 12 equals that, right? They're saying you can double check. 1647 divided by 12 is some number. How do we figure out that our answer is right? We can do this times 12 to see if we get 1647. Notice if I multiply both sides by 12 times 12 times 12, notice the 12s cancel here and 12 distributes into these two. Now, this 12 divided by this 12 will cancel, right? But 12 still multiplies by 137. So 1647 equals 137 times 12 plus 3. So look how this is the same format as this is. Now, 137 times 12 must be 1644, and 1644 plus 3 is 1647. So notice that that's where the remainder comes in. It's the thing that's added to the result of what we could divide by 12 to get a quotient, right? And what they're doing right here is the same thing. They're technically multiplying both sides by x squared plus 3x plus 2, right here and right here. Here, x squared plus 3x plus 2's cancel. This cancels with the remainder, but it does go in with this guy right here, and that's where we have that. This times this, and then you do add that remainder. So I'm not going to get into all the work, but double check, and this ends up being the original dividend that we had. Okay, 20 plus minutes in for that one example, but that's the point of the lecture portion. I am going to be speed running more so through the actual long division problems that we do. I'll give some fair warnings of now this is what we got to check and all that kind of stuff, but there it is. Oh, common error. The expression added to the quotient in the result of a long division problem is the fraction of your remainder, not just the remainder itself. I mentioned that before. When this was an answer of 137 with a remainder of 3, the answer is not 137 plus 3. It's 137 plus 3 over 12, right? The whole idea of the remainder portion is it didn't become a whole number. It remained as a fraction. So just keep that in mind. Okay, let's move on to the next page, and let's go to synthetic division. And yes, there's more I'm probably going to have to stay on synthetic division. There's a shortcut for dividing polynomials by binomials of the form x minus k. The shortcut's called synthetic division. The method will be shown in the next example. Now, there's a visual flair to this thing. In fact, I technically write some of these things different here. You're just going to have to kind of follow along with the process. Here's the thing. We can always use long division. We cannot always use synthetic division. Synthetic division only is used for these things. So consider synthetic division to be a specialty of sorts. However, it's used a lot. It's used a bunch. We divide by linear factors all the time. We do. There are times where if I had a linear factor, I would caution you on using it. It has to do with when there's, if there's a number in front of x. And that's why they say x minus k very specifically. Again, there's a visual flair to this. We're going to have to follow and understand the rules in a bit. But what I'm going to do is take whatever first example that they have. I'm going to do long division with it over here at some point and show you how it ties in with the synthetic division. Again, this is a synthetic means artificial, means fake. It's not true division. It's a shortcut, and it is faster. It's significantly faster. It skirts past the things you don't need to write otherwise, or bypasses them, I should say. I don't know why I'm giving all these fair warning things. I'm giving caution, caution, caution. I just want to make sure that if you get frustrated or lost over these things, number one, it takes practice, whatever. Number two, it's worth it. And number three, there are only certain times that we can use it. But, why does it work? What is it that we're doing with this? I don't know who made it up. Props to them. It's one of those shortcut things. Normally, I'm not a shortcut person. In this, memorize this and whatever else. No, this one actually has purpose and it has meaning and it has functionality and it will always work for this scenario. Okay, so here's the process. We're going to write the coefficients of the dividend in order of descending exponents. So when you have the original dividend, this is negative 1x cubed plus 4x squared plus 0x plus 9. One of the things on synthetic division is, although in long division you don't have to write the placeholders, you must write the placeholders here. This 0 is for the x squared term. If you miss it, you will miss out. Here's the thing on synthetic division. I'm just going to scroll. I want you to take a look at the example. Notice how x's are missing here completely. That's one of the things where synthetic division goes faster. But you cannot let it just go faster without ignoring the fact that there should be, sorry, I said this was the x squared term. This is the x term. You cannot let it go faster unless you at least still follow the construct of what this is. The way that we write this, anyone who reads this is assuming this is the constant, linear term, quadratic term, cubic term. If you leave that 0 out, then suddenly it would just be the constant, linear term, quadratic term. That's not what they were. So we do need that 0 placeholder. It must be. And this must be standard form descending order of degree. Otherwise, it will not work. Because the divisor is x minus 3, we're going to use k equals 3. What is k? K is essentially your root. if we're dividing by a factor, that means x minus k is a factor of this, sort of, because you might have a remainder. But if x minus 3 equals 0, then x equals 3. We're going to use the root value here. Now, there's an important reason that we are using the root in this sense here. You'll see it in a moment. Now, I don't tend to draw it like this. There's nothing wrong with drawing it like that. In fact, it's perfect. What I tend to do is this. I write 3 in a box, and then I write these numbers here. I still draw this line. It's going to be important, but I might do it like this. Sorry if the visual style is different. It's the same thing that we're going to do. Anyway, so I'll continue on mine as they already wrote theirs. There's nothing, again, wrong with what they're doing. I'm going to do the same thing. Step 2, after we set it up, bring down the leading coefficient. You'll see why in a moment, but we're going to bring down this -1, and we still have -1. Multiply the leading coefficient by the k value. -1 is going to multiply by 3. You do -1 times 3, and you're going to write it right here. Write the product under the second coefficient. -1 times 3 is -3. We write it there. Here's the big word. Add. Don't subtract. Add. What is 4 plus negative, not minus? What is 4 plus -3? Well, that becomes 4 minus 3, which is 1. But unlike long division, here we are adding. That's one of the differences between, when I said here's when we use the root. Remember how the root's the opposite of that number? And remember in long division, I'll show you the version of this. In long division, we subtract, but that -3 is involved. That's a part of it. Here we're going to add. Rinse and repeat. Multiply the previous sum by the k value. 1 times 3. 1 times 3 is 3. Add. 0 plus 3 is 3. Multiply. 3 times 3. 9. Excuse me. 9 plus 9 is 18. Now, they wrote all this. Here's their answer. Write the product under the third coefficient. Add. Repeat the process. The first 3 numbers in the bottom row are the coefficients of the quotient, and the last number is the remainder. So, this, I tend to box this one off as well. I think that's part of how I got my box style, that you can see that there's the box right here, just for whatever reason, and there's a box right here. Guys, 18 is the remainder, and these are the coefficients of your new quotient. So, remember how I said this was the constant term and you work upward? Constant, linear, quadratic, cubic. Now, this is constant, linear, quadratic. There's no more cubic. This is the remainder. So, I'll keep going with what they state. The first 3 numbers are the coefficients, last is the remainder. So, -1x squared, boom, plus 1x, boom, plus 3, boom, with remainder of 18. And how do we write that? Plus 18 over the original x minus 3. Okay. So, there's their final answer. There's the result. So, this divided by this equals that here. Now, this did go faster if you know how the process works, significantly so compared to the others. So, let's do the same one in long division. I want to see if you can understand why synthetic division is doing what it's doing. Keep in mind, the big bypass in synthetic division is there aren't any x's. That's the first big bypass. Second big bypass is it does, or not bypass, thing that I think helps people is it does addition instead of subtraction. Now, how does this work and why? Let's look at a long division example of this. -x cubed plus 4x squared plus 9. Now, I can write a space between that plus 9 or not. It's up to you. In fact, let's not put the spacing in between. They said, this is 4x squared, by the way. They said leave that 0x, and you probably should, but you don't have to if you know when you combine and when you don't. Some people might forget to do it, and I want to see if you know what it looks like. So, x goes into -x cubed, -x squared times, and now you multiply these two. X times -x squared is -x cubed. -3 times -x squared is positive 3x squared, and you subtract the result. -x cubed minus -x cubed is 0. 4x squared minus 3x squared is 1x squared. Oopsie. You can use black. And 1x squared plus 9 is here. Now, let's pause for a moment. Let's pause for a moment and compare it to our first step here. The final result of this thing was -1x squared, right? The -1 that goes here with the x squared. So we put down this -1. Notice how we just brought it down. They said, bring down the leading coefficient. Bring down, -1 adds with nothing. How come? Because remember that in this synthetic division, this is the form x minus k, or 1x minus k. You know how many times x will go into your number here, whatever the coefficient is? 1 times anything is just that number. If this is a -1, this will be a -1. If this was a 7, this will be a 7, because this is just a 1x. 1 times 7 is 7, right? 1 times 700 is 700. So no matter what, that will always still be the leading coefficient, because we are always dividing by an x, a 1x minus k. This only works if this is a coefficient of 1. It doesn't otherwise. You couldn't just bring it down. If this was a 2, 2x doesn't go into negative x cubed, negative x squared. It goes into negative 1/2 x squared times, right? So it doesn't work with that unless that happens. There's the first thing. That's why this just gets brought down. Now, what else happened? What else happened? We got to this 1 eventually, right? This 1 is this 1 right here. Well, it will be. It will be. Actually, I think I skipped it. I didn't keep going. X minus 3. X goes into x squared x times. That's this one, I should say. That's this one right here. Okay, that's this one right here. Now, keep in mind, it still follows the construct if this is still a 1x, and that coefficient still kind of goes with it, right? But before I keep going on it, so that's where this one fits here. Now, what are the things that they also skirted past doing? Obviously, they skipped x's, because we're going to know to combine like terms. But you know what else is missing? Notice how we had to cancel these ones out? They don't need to bother with the canceling. They understand in long division that these terms will always cancel out if you're doing things right, if you got the right number and stuff like that. These will always cancel out. So they don't include that in this long division stuff. The canceling's not there. You know what is there? This 4x squared minus 3x squared. Now, what do they do that's different? They don't have x squareds, because they know they're going to combine like terms, because they know you're going to write these in descending order of degree with proper numbers, placeholders and all. You do need the 0 placeholder. They also know that we are subtracting in long division, but they're adding in synthetic division. Why do they get to add, whereas we had to subtract? Because we didn't change our sign. -3 times -1 was +3, but +3 times -1 is -3, because this 3 is opposite sign, because it is the root of the factor. This is a +3, that's a -3. This is negative, we must subtract. This is positive, we get to add. It's not because it's positive we add, it's because it's the opposite sign. It's the opposite sign. So we have to write subtraction. Keep in mind, this is 4 minus 3 to get 1. This is 4 plus -3 to get the same 1. And that's part of how synthetic division is working. Now let's continue into this. I have to do x times 1x to get 1x squared, where those will cancel out. And listen, you could skip past that part if you want to, but I want you to make sure you did it right. -3 times 1x is -3x. Now, what's 9 minus 3x? They don't combine. They don't combine. Do not write 6x. Do not write 6, right? They don't combine. So how do I write it? Well, standard form, -3x plus 9. That's where they recommend a placeholder for long division. This is where you must do it for synthetic division. As we keep in mind, in the next division, x goes into -3x -3 times. Where does this -3 exist? It is... Oh, shoot, I made a mistake. You subtract, 0, I was so focused on this part. 0 minus 3x is positive 3x, right? Subtracting the negative. I never make that mistake. It's just because I'm doing the talk on it. I just did. So positive 3x here. So where do we see this 3? This 3 exists right down there. It's the number that was the result of adding those two things. So there's a great tie-in into these. Now, x times 3 is 3x. 3 times 3 is 9. What did I do? 3 times 3, oh, this is a -3. -3 times 3 is -9. And then 3x minus 3x is 0. 9 minus -9 is 18. So 18 is the remainder here, because x cannot go into 18 at all. So there's a result of our numbers, right? These coefficients, -1, 1, and 3, are these numbers right here. Obviously, we have to write them out. Here's the other part about synthetic division that always works out. Because we're always dividing by a linear factor, we're always just going to go down 1 degree. What happens when you divide x cubed by x? You get x squared. What happens when you divide x to the 5th divided by x? You get x to the 4th. What happens when you divide x squared by x? You get x. You're always going to go down 1 degree than you did before. That's what synthetic division understands, is that this was a cubic coefficient. Now this is a quadratic coefficient. It goes from an x cubed to an x squared. This goes from an x squared to an x. This goes from an x to a constant. This goes from a constant to a remainder. So that's the result, right? That's the visual style. I am absolutely over teaching this. This is going to be the longest lecture I'm sure I'm ever going to teach. This is a lecture that you can obviously skip by if you think you know how this stuff works. Hopefully the lecture makes the problem set go significantly faster. Meaning I'm not going to teach all this stuff. This is like long division, whatever. Guys, this will go so fast. Once you get this thing set up, though, this will go so fast when you do it. I'm giving you the times as to why it works. I want you to understand what it is that you're doing with synthetic division so you don't make any mistakes later. All right, there's another example down here. Using synthetic division, we divide this by that. Notice that this is a linear factor with a 1x, whatever. So that works. Use synthetic division because the divisor is x plus 1. You use a k value of -1 this time, right? If x plus 1 equals 0, then x equals -1. You use this root right there, and they're going to do the same. And then you write out these coefficients. 3x cubed minus 2x squared plus 2x minus 5. And we're going to do the same stuff. We bring the 3 down. We multiply 3 by -1 to get -3. We add these together to get -5. We do -5 times -1 to get 5. We do 2 plus 5 to get 7. 7 times -1 is -7. -5 plus -7 is -12. -12 is the remainder, where this is the constant, linear, quadratic terms. The result is 3x squared minus 5x plus 7 with this remainder, minus 12 over the original linear factor, x plus 1. Not factor, excuse me. It's not a true factor if that's not a remainder, but the linear divisor. It's not often that they do two examples of the same kind of thing in a lecture. Note that dividing polynomials does not always result in a polynomial. This means that the set of polynomials is not closed under division. Yeah, remember, this isn't a polynomial. This, as long as you have a remainder, it's not a true polynomial, right? The quotient's a polynomial, but the remainder with the whole thing makes it non-polynomial. Anyway, let's keep moving forward into what they want to talk about, which is the remainder theorem. Remainder theorem, the remainder in the synthetic division process has an important interpretation. It's not just synthetic division process, it's also long division process. When you divide a polynomial f of x by d of x equals x minus k, the result is here. Hold on. I don't know. Oh, you know what? This is the stuff we were talking about before. So the result, right, f of x divided by your divisor gets you your thing, and this is what the remainder right here. I think they're showing you because in synthetic division, you have to bring your factors back. That you have to make sure you divide by this. But notice how they do what I mentioned before. You multiply both sides by x minus k to get the result. Now, this looks confusing to you, even to me, when you look at this. But if you multiply by x minus k here, cancels, and x minus k here, remember, it distributes. So it multiplies in with that. X minus k, boom, times q of x, and then these ones cancel here. Now, what's the remainder theorem? The remainder theorem shows that your remainder that's added here as a result kind of works. Now, the important aspect of this is, well, here, I'll read what they say, and then I'll kind of talk about it. Because either r of x equals 0, the remainder is either 0, or the degree of r of x is less than the degree of x minus k, a constant. You know that r of x, is a constant function. So let r of x equal r, where r is a real number, and evaluate f of x when x equals k. Okay, what does all that say? Well, we'll see. When you plug in k into here, remember, your root, what happens is the x minus k that was here becomes 0. 0 times anything is 0. Who cares what q of k is? This becomes 0, and this cancels out. It wipes out, I should say. Plus r is just r. The result is stated in the remainder theorem. The remainder theorem is telling you this, guys. The remainder is the constant that you get when you plug in the x value that represents your root from your linear factor. If a polynomial f of x is divided by x minus k, then the remainder is r equals f of k. The number that you can plug into your polynomial function, you will get the same as your remainder result because everything else will wipe out. I know this might sound kind of like blah, blah, blah to you right now. I think as we do more problems, it'll make more sense. I think as you understand factoring later, it'll make more sense. But when we look at one with the 0 remainder as well, I want to show you how that works too. The remainder theorem tells you that synthetic division can be used to evaluate a polynomial function. So what they're saying is if you get a 0 remainder, that means that you could truly divide out of it. That means you'll get 0 out as a result. To evaluate f of x when x equals k, divide f of x by x minus k. The remainder will be f of k. So let's use synthetic division. Remember, you can always use long division, but if it's a linear factor, use this. Use synthetic division to evaluate f of x equals 5x cubed minus x squared plus 13x plus 29 when x equals negative 4. Full disclosure, I want to show you the bottom first. Notice that they said to evaluate this when x is negative 4. Remember when we did, this was in section 3.1, where we substituted negative 4 into, right, f of negative 4, substitute it into x and we evaluate? This might take a while. Negative 4 cubed. Oh, what's negative 4 cubed? Blah, blah, blah. Like that. Oh, actually, this might take a while as well. But negative 4 cubed is negative 64. Times 5 is negative 320. All that kind of stuff. We have to work it out, right? Here's the result. Now, if we use synthetic division, what happens? Bring down the 5. 5 times negative 4 is negative 20. Add these together. Multiply these two. Add these together. Multiply these two. Add these together. This is the remainder. Because the remainder is negative 359, it shows you that f of negative 4 equals negative 359. Now, the reason being is a little, they didn't write it for you. The reason being is because 5x cubed minus x squared plus 13x plus 29 equals, remember, it equals this quotient, 5x squared minus 21x plus 97 times your linear factor, which is x. Your linear factor would have been x plus 4, right? If x equals negative 4, add 4 over. If x plus 4 equals 0, this is your factor. Times x plus 4 with a remainder of negative 359. Notice what happens when I substitute negative 4 into here. This becomes something I couldn't care less. You know why? Negative 4 plus 4 is 0. Negative 4 plus 4 is 0. This wipes this out. All you're left with is negative 359. The reason this becomes negative 359 is because this part wipes out the two things that multiply together as factors. And you're just left with the remainder. Okay, guys. That was a 42-minute lecture, and it's the longest one I'm sure we'll ever have, at least in comparison, not to the problem set, but to how fast I do the problems as a result of it. We still have to do the vocabulary and core concept check, and I think this is the first time we get 4 problems with them instead of 2. So we'll take a look at those, and then we'll do a 40 from numbers 5 through 40. All right, number 1, writing. Explain the remainder theorem in your own words. Use an example in your explanation. Well, I just kind of did, but in my own words, I could state the remainder theorem shows that the remainder, like the results of the remainder, is the same as your output when evaluating x for a specific value. So the example, use example in your explanation. I don't know how deep I want to get into this thing. I'll do a short one. X squared minus 3x plus 2 as my example here, divided by x plus 2, like that. If I use synthetic division, so the way that they would say is like, hey, plug in, sorry, let me do this again, where they say, hey, here's your function, x squared minus 3x plus 2, and they're saying, hey, tell me what f of negative 2 is. Tell me what f of negative 2 is. Okay, I can substitute, let me show you this first. I can substitute negative 2 into here, probably faster. Negative 2 squared is 4. This is plus 6 is 10, plus 2 is 12, right? They want us to show that 12 is what we get as the remainder when we do synthetic division right here. Now, why did I say negative 2 here when this is x plus 2? Because negative 2 is the root that you get with x plus 2 as your factor. So in synthetic division, not that you have to write it like this, but in synthetic division, we're just going to use the negative 2 root for x plus 2. We'll use 1, negative 3, and 2 as the coefficients in standard form of the original function. We bring down the 1, we multiply by negative 2, we add these together, we multiply by negative 2, we add those together, and we get 12. 12 is the remainder, right? Here's a quotient, great, x minus 5. That does mean that x squared minus 3x plus 2 equals x minus 5. That is a 2. Oh, I can write that though. X minus 2, because, or x plus 2, this factor, times the new quotient x minus 5, with a remainder of 12 plus 12. Now again, how does 12 work as the answer when you plug in negative 2? Because negative 2 plus 2 is 0. 0 times anything is 0 plus 12 is 12. And you saw that that's how that works. That's why the remainder theorem does what it does. All right, number 2, vocabulary. What form must the divisor have to make synthetic division an appropriate method for dividing a polynomial? Provide examples to support your claim. There's an example up top. I don't want to keep doing examples each time here. It must be in the form x minus k. See example above. And because I did the whole example there, keep in mind it must be in the form x minus k. It must be a linear factor with a linear coefficient of 1. If not, it will not work. The reason that my 42-minute lecture is so long is because I showed things like that. I need you to make sure that you get that it must be that. Otherwise, we got to either use long division or force linear factors into your answer. Number 3, vocabulary. Write the polynomial divisor, dividend, and quotient functions represented by the synthetic division shown at right. Oh, right here. So, excuse me. The divisor would be, let's use a different color. Actually, let me do the dividend first, because the dividend's the top number, right? The dividend. Oh my gosh. The dividend is, remember, this number is going to be your constant, right? So constant, linear, quadratic, cubic. 1x cubed minus 2x squared minus 9x plus 18. The divisor is what we're dividing by. We're not dividing by negative 3, guys. We're not dividing by negative 3. Negative 3 is the root where x would equal negative 3. So if you add 3 to both sides, you get x plus 3 equals 0. Your divisor is x plus 3. Okay? The quotient, I should have written q of x and stuff like that. The quotient is the result that's in red, because remember, this is the remainder in blue, and I just answered that part. The quotient is 1x squared minus 5x plus 6. Remember, this was the constant, now it's the remainder. Linear, now the constant, so right there. And then cubic, now quadratic. There's the quotient. The remainder is 0. I know they didn't ask for it, but I want to remind you that that's what we have. If remainder is 0, that means it's a perfect factor. Cool. Number 4, writing. Explain what the color number... Oh, that's what number 4 was all about. Okay, red is the quotient, and blue is the remainder. Okay? Okay, guys. Super long stuff leading into our problem set, and I'm going to start the timestamp stuff right now for problem number 5. So starting in 3, 2, 1, go. Okay, we're going to start with our problems 5 through 40 stuff. We're going to do polynomial long division to begin with. I want to let you know right now, if you skip the lecture, the 48 minute lecture, I understand it, but I'm going to go through these problems whiz bang. The reason the lecture was so long is because I slowed things down there. I'm not going to slow things down over here. Okay? I'm not going to slow things down over here. So, the lecture portion was for what it was. It was a long lecture. I apologize for that. It's as long for me as it is for you. Oh, what just happened? It's as long for me as it is for you. So I want to make sure that you feel out what's going on there. Okay, number 5. We're going to divide x squared plus x minus 17 divided by x minus 4. We're going to use long division for it. Could we use synthetic? Yes. Are we going to? No. They asked us to use long, and that's okay. We can practice some of these. Remember, you can always use long division. There are only some cases, like this one, where we could use synthetic division. All right, x goes into x squared x times x is x squared. Negative 4 times x is negative 4x. Subtract the result. X squared minus x squared is 0, as should be. X minus negative 4x is 5x. Remember, you subtract that result. Negative 17 minus 0 is negative 17, and we bring that down. We continue forward. X can go into 5x as well. It goes into it 5 times. X times 5 is 5x. Negative 4 times 5 is negative 20. And keep in mind, we are subtracting here as these cancel. You don't do negative 17 minus 20, but negative 17 minus negative 20, which is negative 17 plus 20, which is 3. Now, remember, some teachers might put a minus here and a plus here and change all their signs. I do not. It's just a thing I don't do. There's a remainder of 3. So divide using polynomial long division. Okay, well this equals, I'm going to write them in green, I guess, as the answer. Your quotient, x plus 5, plus your remainder. Your remainder isn't just 3, but it's 3 out of x minus 4, the original divisor that you have there. And that's the answer to number 5. Now, if that felt fast in the way that, like, not like oh, wow, you're so fast at it. I mean, if that seemed like I rushed, that's because I slowed down during the lecture portion. So if you're like, whoa, Mr. Robinson, what are you doing? How did you do that so fast? Wait, can you explain it? 47-minute lecture or whatever it was. So dive in that. The long division part isn't that long. I'm just stating that go to the lecture portion and find what you're looking for on it. All right, number 6, 3x squared minus 14x minus 5 divided by x minus 5. And I want to keep restating anytime it shows up that as long as I have linear factors, you can use synthetic division on these ones. It's possible. Not going to here. Okay, compare the leading terms. X goes into 3x squared 3x times. So you multiply those, you get 3x squared, as should be. Negative 5 times 3x is negative 15x. I say as should be because these should always cancel here. Negative 14x minus negative 15x is 1x. And you have a minus, this was a 5, it's just a terribly written 5. 5 as well. And you might already notice what's going to happen here. I need to see how many times x goes into x. Technically, we're trying to see how many times can x minus 5 go into x minus 5. But x goes into x one time. X times x is x. Negative 5 times 1 is negative 5. And when these subtract, both cancel out to the tune of 0. 0 is your remainder. If 0 is a remainder, nothing that needs to be added to your quotient. Your result is your quotient, 3x plus 1, and boom, that's the answer. As a double check, that would mean that 3x plus 1 times x minus 5 equals this. That's actually, it means it's a perfect factorization. We don't do factoring until next section, but we could have technically factored that, which is pretty neat. Number 7. We have x cubed plus x squared plus x plus 2 divided by x squared minus 1. Now, from the initial appearance of this, technically synthetic division can't be used. There is a way that you could use synthetic division if you factored this thing out and difference of 2 squares and all that stuff. But this would be quicker actually this way. Use long division for this. X squared goes into x cubed, only x times, right? X squared times x is x cubed. Negative 1 times x is negative x. Now, I would write that right here, line it up with the term that you have that makes it work. Now, these ones cancel. Do these ones cancel? No, be careful. Remember, these cancel, they're both positive and we're subtracting. 1 minus negative 1 is 1 plus 1, which is 2. We get a 2x. But don't forget everything else. X squared is here and 2 is here. We keep going. X squared goes into x squared exactly one time. And x squared times 1 is x squared. Negative 1 times 1 is negative 1. Again, write it underneath the 2 where it can combine. That will help you out. Those cancel. 2x minus nothing is 2x. 2 minus negative 1 is 3. All right. X squared cannot go into, I'm going to write this down here. X squared cannot go into 2x any number of times. That means that 2x plus 3 is going to be dividing out with x squared minus 1. So in our final results of this thing, I need to write some room, this becomes x plus 1 is your quotient with the remainder of 2x minus 3 out of x squared minus 1. That is as deep as we can get with it. Bigger remainder than it is a quotient, as so it seems, but we're done. Okay, number 8. Number 8. There is no time on number 8 that I would ever consider using synthetic division. I probably wouldn't have in the initial, and number 7 either, but x squared plus 1 can't factor with real coefficients, so, or with real factors. So long division it is. Not just because they forced it on us, because you should. Okay, let's see what we get here. X squared goes into 7x cubed 7x times, right? 1 times 7 is 7. X squared times x is x cubed. So we multiply that result. We get 7x cubed, as we should. 1 times 7x is 7x. Let's write it over here, as it will combine with our x term. Okay. Get a cancellation here. We bring x squared down, and x minus 7x is negative 6x. Now we check this again. X squared goes into x squared one time. X squared times 1 is x squared. 1 times 1 is 1. Now, I can either write the plus 1 right here or kind of move it off to the side as it can't combine with the negative 6x. And these will go bye-bye. Negative 6x can come down. But remember, this is 0 minus 1 that's happening. This is a negative, 0 minus 1, which is negative 1. Don't just put plus 1 and bring it down. We are subtracting. Listen, if you do need to do the minuses and stuff like that, more power to you. Just make sure that you know what's happening. Have your own process. That's really where I want to explore with you guys. I say, have your own process. Make it work. X squared cannot go into negative 6x minus 1. This is the larger degree than that, so this will be the remainder. So the final results of this one is going to be quotient, and then this remainder. Now, there are different options in how you can write this remainder. You can do it like this straight up. It's a little iffy. I don't love the appearance because of the leading negative. Granted, this term is negative as well, but I don't care about the second term. It's the leading term that's negative that I don't like as much. So this is an answer. My preferred answer is factoring the negative from the top, meaning negative 6x minus 1 is also the opposite of 6x plus 1. You know what I mean? So instead of writing this as a plus here, I could write it as a minus, and in the future I'll be doing this, minus, and then 6x plus 1 can be the quantity there over x squared plus 1. So notice what I did there factoring out a negative. That is a pretty common practice as far as math simplification, or just the way that accepted answers and stuff goes. So both work, and I get why you might write this, but if it was multiple choice and this option wasn't there and this was, right? Go with that. And it wasn't because the 1 was negative. It's because the 6x was negative. I don't like adding negative. Who does? Okay. I did promise to go faster, and now I will. Number 9. On number 9, they have 5x to the 4th minus 2x cubed minus 7x squared minus 39. Notice the x term is missing, by the way. I want to bring it up now, and don't you forget it. Okay. 5x to the 4th minus 2x cubed minus 7x squared. Now, what the book preaches, what I would also probably recommend you do, is include a placeholder here. There is no x term, so it's best you place 0x. When it comes to synthetic division, you have to do it. When it comes to long division, you probably should. Not a requirement. There are ways to go around it, and it looks like the next problem also skips several degrees, or 2 of them. So I'm going to try it without a 0 placeholder on some of those in the next one. Anyway, check leading terms. X squared goes into 5x to the 4th, 5x squared times. X squared times 5x squared is 5x to the 4th. 2x times 5x squared is 10x cubed. Negative 4 times 5x squared is negative 20x squared. These poor guys get nothing to combine with, as this cancels. Negative 2 minus 10 is negative 12. Negative 7 minus negative 20 is negative 7 plus 20, which is 13. Down we go. Down we go. X squared goes into negative 12x cubed. Again, you might slow down on those and go, wait, how does that work? Just one thing at a time. 1 times negative 12 is negative 12. X squared times x. Sorry, I said this wrong. 1 times negative 12 is negative 12. X squared times x is x cubed. There we go. So x squared times negative 12x is negative 12x cubed. And remember, this should end up canceling when you do that. But 2x times negative 12x and negative 4 times negative 12x. This is where that placeholder is going to be nice because you know that these are to combine, not these two. You should know what combines and doesn't because x's are there versus not, right? You only combine like terms. 13 minus negative 24 is 37. 0 minus 48 is negative 48. Negative 39 comes on down. All right, x squared goes into 37, x squared exactly 37 times. And we get 37x squared. 2 times 37 is 74, I think. And negative 4 times 37 is negative 148. All right, no one ever said these answers will look good. As a result of this canceling and then subtracting, negative 48 minus 74 is negative, negative 122. And then, remember, this is going to be addition, negative 39 plus 148. So 148 minus 39 is the way I can say that. Is that 109? So plus 109, I believe there. Now, this is the remainder because this has an x squared. So let me write this one down below. I probably can't fit this one on top at all. So the results of this one is this quotient with this remainder. Now, as I stated, I'm going to factor out the negative from here. So make it a minus, and now this will become positive, and this will become a minus there. I don't know if the book would do this as far as like answers in the back and stuff like that. You can check. It's an odd number. But that's how I would end up writing that result personally. I'm big on putting the minus if I factor out the negative there. No plus negatives for me, please. For you, sure, do whatever you want to do there. If they put plus negative, fine. Fine. Like I said, no answers have to be pretty. A remainder is a remainder. And heck, if you plug in 1 for this thing, maybe it's a really clean number. Maybe it becomes 3/4 or something. I don't know. That's not the point. I probably will attach my other worksheet thing that I have, because what I did was I made sure all of them had 0 remainders. So the thing about these problems as a student where you might feel uncomfortable with doing them is you get this remainder and you have no idea whether it's right or not. I get the remainder and I have no idea whether it's right or not. To me, it looks like weird numbers. I'm like, did I do the problem right? I'm going to trust my own math in that I did the problem right, personally. Me. I'm going to trust my own math on it. You might go, something could have gone wrong, right? 13 minus negative 24. Did you do plus? You know what I mean? Did you accidentally subtract once? It takes one false subtraction to not only change that part of the answer, but it changes everything, because now x squared goes in that many times and you distribute with that. It changes everything. So you as a student, I can see where you might question what your thing is when it gets to it. I'd probably like where more teachers, when they test and say like, note, your remainder should become this number. So you're like, all right, I made sure I did it right, the long division, but I get it. But that's where I like my other worksheet thing, where it's like, if you got a remainder of 0, you know you did it right. If you didn't get a 0 remainder, you know something went wrong. So the first time I like to teach it is making sure I give you 0 remainders. This doesn't. It might not. We don't guarantee 0 remainder here. So that's kind of the difference in these two. Okay, let's keep going. We have la division of les langues. Now, this one here, keep in mind, there is no x cubed term, there is no x squared term. Let's try it without actually writing those as zeros, though. You can do it however you want, but I'm going to write it shorthand just like this. We understand that we should only combine like terms. I sure hope that you do understand that, and that you're subtracting the underneath guy. X squared goes into 4x to the 4th, 4x squared times. Now we multiply these. X squared times 4x squared. Negative 3 times 4x squared. Negative 2 times 4x squared. Negative 2, times 4x squared. Now we subtract. Now, these cancel. Do I combine these two? No, that's a cubic. Do I combine these two? No, that's a linear. I just wrote them where I wrote them. This is where you might say, well, I think I prefer putting the zeros and stuff. And I'm not shying you away from doing it. Please, by all means, please do it. This just may be a habit of mine where I don't. And you must do it for synthetic division. But note that there is no zero, there's no x cubed term here, so it doesn't combine. So I bring this down. But I have to subtract. 0 minus 12x cubed is positive 12x cubed. 0, these combine. Wait, did I mess something up? This should be minus 8x. Is that a minus 2? Hold on. What did I do? Oh, this is 8x squared. Okay. 0 minus 8x, negative 8x squared is positive 8x squared. And then bring down the 5x minus 0, negative 4 minus 0. There we go. So anyway, if that's more of a headache for you, I get it. I'm just showing you every which way that you can do it. Because you might say, I like 0 placeholders more, but you have to remember to write it. So if you forget to write it, you should still get this. Anyway, x squared goes into 12x cubed, 12x times. Let's speed up the problem now. Minus, because every time there's something new, I want to introduce it. And that was kind of the new thing I wanted to introduce there. All right, so 8x squared plus 36x squared. Why did I say plus? Subtracting the negative. 5x plus 24x, and negative 4 goes there. So even though there were no placeholders to begin with, it seems like now there are things to combine, right? X squared goes into 44x squared 44 times, and you get 44x squared minus 132. x, and then minus 88. You know, there's something else I do in that other video of mine. I just remembered. I recorded it a couple years ago, I think. But I write out the result as how you can multiply things together because it's a zero remainder. I talk about the factorization of some things. I probably do it a little bit differently than you'd be comfortable with, but just practice the division itself. You'll be good. So anyway, we get that remainder, right? So now we write that remainder with the quotient. So this all equals, I can't fit it up there. That's fine to write it down here. That divided by that equals 4x squared plus 12x plus 44. Plus 161x plus 84 over x squared minus 3x minus 2. And the reason I thought about what I wanted to say with that is because we practice factoring more in that video as well. So I know that video is factorization. I bring that up because this has a common factor of 4. And I was like, do we have to write the common factor of 4? No, we're just going to leave it like that. We're writing the quotient and the remainder, and we're good. All right, there's some long division problems. Here comes synthetic division. Watch how fast these go. Now, keep in mind, I'm going to look at all the problems first, scan through them, and make sure that they are all in this x minus k setup, that they are linear factors you're dividing right here. By x minus k, it doesn't mean these all have to be minuses. Whoopsie. Doesn't mean these all have to be minuses. What it means is that you need to have a linear factor with a 1 coefficient. So, yes, 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 yes. Perfect. Okay, they are all synthetic division friendly. They will be pretty straightforward and fast when it comes to doing them. X squared plus 8x plus 1 divided by x minus 4. Now, your root is x equals 4, right? If x minus 4 equals 0, then x equals 4 is the root. So we're going to place 4 as the root. Remember, I have a different visual flare of that box up there, but that's okay. I got a 1x squared plus 8x plus 1 as my coefficients. Bring the 1 down. 1 times 4 is 4, 8 plus 4 is 12, 12 times 4 is 48, 1 plus 48 is 49. The result now is, here's the remainder constant linear term. The result is x plus 12, 1x plus 12, with a remainder of 49. That means that's 49 divided by the x minus 4 that was there. There is your result. Significantly faster than long division, and I would always recommend, listen, I'm one who does not like shortcuts in a lot of things. I always recommend this shortcut because everything that I talked about in like that 47-minute lecture of why it works, when it works, how it works, and really what we do with it. The use of division, specifically of linear factors, is massive, even like in IM3 and upwards. We do it a lot. We do it a lot, and we need to just save time. And that's a good time saver. All right, 2 is the root on number 12. And we're going to write out our coefficients. 4x squared minus 13x minus 5. And I say those out loud for a reason. I want to make sure I'm going down in descending order of degree, the next degree over. Placeholders, 0 placeholders have to come in a second. Bring down the 4. 4 times 2 is 8. Negative 13 plus 8 is negative 5. Multiply those, you get negative 10. Add those, you get negative 15. And we get quotient and remainder. So the quotient is 4x minus 5. The remainder is negative 15 over x minus 2. Like that. Now, once again, Mr. Robinson, that went really fast. How did you do that? I mean, lecture, right? Jump to the lecture portion. Now, the other part of this that I want to keep reminding you is that because there are no x's that are written here, remember, we went from an x squared. Since we divided by x, we went from an x squared to an x. That's how we know that that's an x, not an x squared. All right, number 13. Number 13. 2x squared minus x plus 7. Honestly, I think me writing down the problem is longer than me doing the synthetic division itself. Divided by x plus 5, or setting it up, I should say, as well. Negative 5 is your root this time, right? It shows a plus. So this is a minus. Yeah, do you flip the sign? Yes, but it's about what your root is. I need to stress that. 2, negative 1, and 7 are your coefficients for your quadratic linear constant terms. Bring it down, multiply, add, multiply, add. Again, the remainders, whenever they're so big for me, I'm like, ugh, that feels icky when they're such big numbers, but they are what they are. Anyway, the result is 2x minus 11 plus 62 over x plus 5. Again, much faster than long division. Because it skips the x's, right? It skips the x work. It skips the cancellation of what you have to do. You get to add instead of subtract results. I love it. All right, x cubed minus 4x plus 6 divided by x plus 3. Now, I mentioned zero placeholders aren't required for long division, and they're not. They are required for synthetic division. They are a requirement. You can't go without it. Here's what you don't do. You don't do 1 minus 4 and 6. There's an x squared term that's here. It's 0x squared. You're missing it. We need to include it. We are doing 1. That's 1x cubed plus 0x squared. Without it, synthetic division. Remember, the synthetic division ignores x's. It is trusting that you're setting up the problem the right way. 1x cubed plus 0x squared minus 4x plus 6. Now we go to work. Bring it down, multiply. Add, multiply. Add, multiply. Add. Remainder result, right? So here we go. This becomes 1x squared minus 3x plus 5 with a remainder of negative 9. And there's your linear factor. So that's the result. I shouldn't keep saying factor. There's your divisor. So there's the result of that guy there. Yeah, if there was no 0 there, it completely changes your answer and it changes the viewpoint of it. Remember, this was an x cubed. It should become an x squared. All that good stuff. Okay, number 15. By the way, that's probably, I haven't looked at it yet. That's probably going to be one of the error analysis questions that they skip a placeholder. And I'll be good on correcting it because that means that it'll be a fast question. All right, x squared plus 9 divided by x minus 3. Once again, we need a placeholder for the x term. So 3 is your root. I got 1x squared plus 0x plus 9. 1 times 3. 3 times 3. 9 plus 9. Our answer is x plus 3 plus 18 over x minus 3. Okay. Right? Pretty whiz-bang. Pretty whiz-bang on those. I think even on the last two, I might even just do in silence and just the like, all right, are you ready to go? You want to do a speed run? Yeah, guys, we'll do a race on the last two, okay? Here's the last one to kind of teach you about placeholders. So we got 3x cubed minus 5x squared minus 2 divided by x minus 1. So 1 is your root. 3x cubed minus 5x squared plus 0x minus 2. Bring down the 3, multiply it with 1. Bring down the, or add them. Multiply by 1. I guess this number just goes up here. Add them, multiply by 1. And then negative 4 when you add those ones as well. Okay, fit that. 3x squared minus 2x minus 2 minus 4 over x minus 1. Oh, it just fits. It's kind of, I hope you can like see that just fine and you're not like, it's running off the page. All right, 2 more. Number 17, number 18. Now, you know what else? So, I don't know why I thought about this. I do know why. I don't know why I'm telling you. You know, we're going to race, okay, guys? We're going to race. Now I first got to copy down the problem. But the next part I got to do is set up the part. Our race isn't going to be in the setup. It's going to be in the synthetic division part itself. Minus 12 over x minus 6. What I was going to say was I can tie my shoes really fast. I don't mean like I can do the process really fast. I mean I have a faster process for shoe tying. It's not the loop, swoop, and pull like Big Daddy would say, Adam Sandler. But it's a different actually method. Anyway, the reason I bring that up is because it's the part that you have to make it show the bunny ears stuff. But first you got to do the other part. I'm like, okay, I'm slow on that first part, just going underneath and whatever. And then you got to do the other part after. So my setup's going to be slow. We're not racing yet. This is that setup before we race for shoe tying. All right, anyway, 6 is your factor there. And there we have that. Okay. Get your pencil ready. We're going to, I'm not even looking at the numbers anymore. I don't know what they were. Okay, we're going to go synthetic division. Remember, bring your first number down, then multiply by the thing. Then add, multiply, bring it. Add, multiply, bring it. All right, ready? 3, 2, 1, go. Whoops, I want to make sure I do it right. Okay, done. All right. How'd we do? How'd we do? I messed up in one. I didn't mess up, but I slowed down in one portion. All right. This was a quartic. Our result's a cubic. That's 1x cubed plus 1x squared minus 2x plus 1. Minus, and this is 6 all over x minus 6. Okay, number 18. Let's do the race again. Now, there's a placeholder value that we're going to have to put in. Keep that in mind. So we're going to set this up together. Then we'll race. Okay. All right, guys. And what is our root today that goes in my little box? -5. Good. I hope you said that. And then, what are our coefficients? What do we write here? 1. That's where we start. What term goes next? This is Blue's Clues. This is Dora, man. 4. 4 in Spanish is cuatro. Does 16 go next? No, we need a placeholder value for x squared, which is 0. And then 16 followed by -35. Okay. Are we ready? 3, we're racing. 3, 2, 1, go. All right, done. Okay. So take a look. Keep in mind these numbers multiply by -5, and they go up there for the next value. They go up there, up there, up there, up there, and you add down lists. Okay, now what's our final result? As a quotient, this is x cubed minus x squared plus 5x minus 9. The remainder's 10, so 10 over x plus 5. All right, I hope that you love synthetic division and appreciate it for what it is. Remember, it only works for linear factors such as these ones that you're seeing there. All the ones that they had set up for you, that's when synthetic division is allowed. Okay, let's keep moving forward. Let's go to numbers 19 to 22. Match the equivalent expressions, justify your answers. Given that all of these are already dividing by, here, let's do this. I am actually going to straight up copy and paste these. Should I? Yeah, I'm going to move the thing for 1 second. I want to copy and paste it. I'm going to straight up copy and paste these ones in. Normally I don't do that kind of stuff, but because we're doing a matching thing, what I want to do is just one synthetic division at a time in that upper right corner, and then I'll just do the next problem, stuff like that. Hope that makes sense. So we still got to, and here's the thing, I'm going to use synthetic division, right? They're all linear factors. Synthetic division is the most appropriate kind to use. So let's start with number 19. Now on all of these, guys, what we can always affix on these is that 2 is always the root. These coefficients are all the same except for sign changes, right? What's the difference in sign changes here? We have a 1 here and a 1 here and a 3 here. Sometimes some of them turn negative, sometimes some of them turn positive. So this one here is negative for number 19. For number 19, okay? So let's go ahead and do these ones. Bring the 1, multiply the 2, add that, multiply the 2, add that. So this result is going to be, for number 19, x plus 3 with the remainder of 3 over x minus 2. That's going to be option D. Number 19 is option D. Okay, let's go to number 20. Let's do the same stuff here. I guess the 1 is always brought down as well, so we can even do that, right? I'm just trying to speed up the process of these 4 problems. So number 20, it's a -1 and a -3. Oh, I gotta move these. It's a -1 and a -3, and the same root of 2, the same coefficient there. So let's go. 1 times 2, add those, times 2, add those. All right, now we're going to get 1x plus 1, or x plus 1, the remainder of -1. X plus 1, the remainder of -1 is a. All right, let's go to number 21. This time, just the 1 is negative, so get rid of that. All right, let's try it again. Oh, I didn't want to get rid of that. But bring down the 1 times 2, add that times 2, add that. x plus 1 with a remainder of 5. X plus 1 with a remainder of 5 is C. And oh, I didn't move these. I'm sorry. 20, 21, shoot. I'm bringing it down on this set. And finally, number 22, shoot. I was wondering what I should have been doing on that. Number 22, they're all positive. Oh, the first one is negative, I see. They're all positive. So here we go. We'll do the same thing. Bring it down, multiply, add those, multiply, add those, and we get a remainder of 9, x plus 3 with the remainder of 9. That answer is B. Okay. Justify your answers. I just did through my work shown on those ones. Okay, numbers 23 and 24, error analysis. Describe and correct the error in using synthetic division to divide x cubed minus 5x plus 3 by x minus 2. Okay, now one mistake they did, I'm looking at both things here early on to see would they do it. One mistake they do not show is, notice how it says x minus 2 as your factor. That would mean 2 is your root. They did correctly use 2 as your root both times on here, okay? There are often times where people will not put that, and so that was a mistake I expected to see, but it wasn't here. All right, what did they do wrong here? They got 1. They do have the 0 placeholder, negative 5 and 3. So far, so good. Bring down the 1, multiply by 2, add, multiply by 2, add, multiply by 2, add. So far, so good. We got a remainder here, and we got this result. Oh, here's the problem. The problem is this should be x squared and 2x and a minus 1 with the remainder of 1. So they didn't reduce their degrees by 1 here. So there we go. Everything is correct on the setup and execution of synthetic division. Synthetic division. However, their answer does not have a reduction in degree of each term by 1. The leading term should be quadratic. Because they start off with a cubic, right? So in correcting it, I'm not going to do any changes on anything else except just write. And listen, the way that they wrote this part is, and I haven't been writing it like this before, but an x cubed minus an x or divided by an x should be an x squared. So this should be look at their coefficients, 1, 2, negative 1. It should be 1x squared plus 2x minus 1. The remainder is a 1, so this is plus 1 all over x minus 2. Keep in mind that x minus 2 was that original factor, so that's the change we need. Okay, number 24 has an error that I expected them to always put, and they are here, and you can tell that compared to number 23, it is the 0 placeholder that is missing. Here we're correctly putting 1x cubed plus 0x squared minus 5x plus 3. Notice the 0 placeholder is missing, and it clearly changes your answer. Clearly changes the results of here, changes what they put for these things. They put an x squared term, a linear term, no constant term, and they had a remainder. Everything's kind of going wrong with that. It goes way off the rails after that, basically. They are missing their 0 placeholder coefficient for the missing quadratic term. In turn, their answer's kind of wonky. I get that they understand that their final answer should be an x squared if this was an x cubed. That's why they're putting x squared, and we should as well. And that the last number should always be a remainder. But like I said, the constant gets lost in the process. That's really because of this problem, though. So as a whole, that's the issue. So we can correct it, but it's the same problem as this one. So I don't need to redo it. So the correction is here. This is the correct work. Correct work already provided. Okay, let's keep moving forward. My head's scratchy. Sorry I keep doing that. It's like, I want to itch it. All right, numbers 25 to 32. Use synthetic division to evaluate the function for the indicated value of x. Okay, so here's their idea, and I'm probably not going to double check the majority of these, and I already mentioned a lot of that in the big lecture. The idea is, if I substitute negative 1 into this expression, I'm going to get a number. When I use synthetic division, the remainder should be that same number. let's mentally see what number we'll get first. Negative 1 squared is 1. Opposite that's negative 1. Negative 8 times negative 1 is 8. 1 plus 8 is 9. 9 plus 30 is 39. Okay, when I do synthetic division on this, I should get 39 as my remainder. That's the only thing we're looking to do. We're trying to find out what f of negative 1 is going to be. Now, I feel like plugging in negative 1 is probably faster, but there are a lot of reasons we still got to use synthetic division for ourselves in other kinds of problems. So, negative 1 is indeed your root. It's not opposite of this. This says x equals negative 1, not x plus 1 as a division. So negative 1 is your root. Negative 1, negative 8, 30. Bring it down. Multiply. Add them. Multiply. Oh, did I do something wrong on the first? Oh, that was a negative 1. I'm sorry. This was negative 1 plus 8 plus 30. Okay, which is 37. My bad, my bad. I said that wrong. I said negative 1 and then I said 1 plus 8. Anyway, 37. So 37 is that guy there. That's going to be the answer for f of negative 1. F of negative 1 equals 37. Boom. And that's what we're doing. That's what we're doing to evaluate it for it. So substitution, we get 37. Good thing I did the remainder version. All right, number 26. Same-ish. Listen, these problems aren't going to change at all. What we're doing is the same thing. So pretty soon this will go pretty whiz-bang, okay? So f of x equals 3x squared plus 2x minus 20. X equals 3. In substituting 3 for x, we get some number. In using synthetic division, the remainder will be that same number. 3 is the root. We got coefficients of 3, 2, and negative 20. Let's go to work. Multiply, we get 9. Excuse me, uh-oh. What did I just say? Bring it down. Multiply, we get 9. Sometimes I want to teach more than I want to do. And add those. After that, we get 13. So the remainder is the result of substituting 3 into this equation. F of 3 is 13. I want to double check that one more time. 3 squared is 9 times 3 is 27. Plus 6 is 33. Minus 20 is 13. You can see those numbers come in, right? Remember when I said 3 squared is 9? That's this. Plus 6. Well, didn't really show up. Plus 6 is 33. Wait, what? I don't know. Okay, I guess that didn't show up. I thought this would show up somewhere. 3 squared is 9 times 3 is 27. Okay, I didn't see 27 here. Plus 6 is 33. There's 33. The result there is the constant of that guy. I guess I'm speaking out of my butt on some of that. All right, number 27. Now that I realize what I should have thought. Okay, number 27. We get f of x equals x cubed minus 2x squared plus 4x plus 3. I don't see any placeholder things we're going to need. X equals 2. All right, here we go. We got a 2 root and 1, negative 2, 4, 3. Here we go. In silence. All right, 11. 11's that value. 2 cubed is 8, minus 8 is 0, plus 8, plus 3 is 11. Yes, f of 2 equals 11. You're like, Mr. Robinson, if you can do the substitution faster, why are you doing synthetic division? Again, they're asking us to. They're having us understand the idea of how remainders are utilized in what we do. Number 28, f of x equals x. Okay, negative 4 is our root. Here we go. 1, 1, negative 3, 9. Bring our 1 down, multiply by negative 4, add them, multiply by negative 4, add them, multiply by negative 4, add them. Negative 27, and I'm not going to double check that one, I'm going to trust it. Negative 27 is the result of substituting negative 4 into there if we had to. Yeah, synthetic division really has its purposes, right? And we not artificially use synthetic division. There are reasons behind it, but we're manufacturing synthetic division out of a problem that didn't even kind of set us up for it. Long division, I would not want to use long division for all these problems to do it. I would much rather use substitution at that point. I think at some points here I rather would anyway. But yeah, synthetic division, really fast. I really love it. All right, I see a placeholder 0x squared here, right? 0x squared means I need to place a 0 inside there. So 1 x cubed, 0x squared, negative 6x, and a 1. So here we go. 1 times 6, 0 plus 6. I don't know why I thought about that. 6 times 6, add that. Multiply. Ooh, this is a big one. Multiply, we get 180. And we got 181 as remainder. I believe it. 6 cubed is 216. So I believe that this is going to be a big number. They're not really trying to get 0 remainders yet, right? Have we gotten a 0 remainder yet? I don't think so. All right, number 30. Once again, a placeholder, and it's a placeholder for the same degree. It's the x squared term. So f of x, we got x cubed minus 9x minus 7. We're substituting 10 into here. This is going to be 1,000 minus 90 minus 7. It should be 903, I think. We'll see if we get 903. 1x cubed, 0x squared, negative 9x, negative 7. Here we go. Let's take a look. A lot of multiplying by 10s is going to get these numbers bigger for sure. So, times 10, add, times 10, add, times 10, add. 903. Is that what I said? I don't know. You can rewind. 903. So, f of 10 equals 903. All right, two more of that sort, 31 and 32. What's different on these? I have no idea. Still a placeholder. Practice. All right, which one's missing here? The x cubed. Okay. So, we evaluate f of 3. Let's give it a shot by using synthetic division and get the remainder. 1, 0x cubed, 6x squared, negative 7x, and 1. I'm going to go fast on these ones here. $114. Is that right? I think so. So 115 is what happens when you substitute 3 into that. And the last one is number 32 for this set. Oh, okay. Here we go. Let's see. Negative x to the fourth minus x cubed minus 2. Okay. Got a couple placeholders to put in, right? We're missing an x squared term and an x term. So we don't just put 1 0 in. Negative 1, negative 1, negative 1, plus 0x squared plus 0x minus 2. So multiple. Multiple, multiple. Bring it down, multiply. Bring it down, multiply. Not bring it down, add. Add, multiply. Add, multiply. And add. Yeah. Let's go. Right, 5 to the fourth is 625. So let's see, minus 7. Yeah, that's the answer. Okay. All right, so f of 5 equals negative 752. Okay, getting an idea of things here and there. Hopefully that's making a lot of sense. Number 33. Use synthetic division to divide f of x by x minus a and find the remainder equals 15. Your friend concludes that f of 15 equals a. Is your friend correct? Explain your reasoning. They have it slightly backwards. Oh, friend. Close. I'll say my friend is... Let me type it. My friend is close. Instead, it is that f of a equals 15. Explain your reasoning. I don't know. The remainder is the results of this part that you do the substitution thing of, right? We're substituting a into our thing. 15 comes out. Right? That's all. Just it's backwards. Number 34, thought-provoking. A polygon has an area represented by a equals 4x squared plus 8x plus 4. The figure has at least one dimension equal to 2x plus 2. Draw the figure and label its dimensions. So 34, a equals 4x squared plus 8x plus 4. And one dimension, let's call it the width. I don't know if it's width or length yet. I don't care. But width is 2x plus 2. They said polygon has an area represented by this. They say thought-provoking because normally those are ones where they say it has a dimension of that. So maybe they do mean it's a rectangle. I guess it could be a parallelogram of some sort. But basically, we got to do a division. We got to do this divided by that, right? 4x squared plus 8x plus 4 divided by 2x plus 2. Now, here's the thing, and this is a big thing. This is where synthetic division is maybe not advised. Because you do not do negative 2 as your root when you do this thing right here. Because this is not x plus 2, it's 2x plus 2. You can use synthetic division, but it would take requiring that you know what's going on with this thing. I'm going to start with long division to make sure we know what the answer is, and I'll show you what you can do using synthetic division. There are multiple ways you can go about it. And listen, factoring is probably an option too, but factoring is the next section. But yeah, there are multiple ways we can go about this thing given that. But let's start with long division. Let's do 2x plus 2. Let's just revisit it. That's probably part of the trick of this problem. They're making sure that you're getting some things right with it. 2x goes into 4x squared 2x times. You're like, oh, this is long. It won't take too long. 2 times 2x is 4x. Subtract. You got to make sure you know how to do it still. Subtract and you get 4x here. Plus 4. And 2x plus 2. 2x goes into 4x 2 times. And 2x times 2 is 4x. 2 times 2 is 4. And your remainder is 0. Cool. There's a 0 remainder. So we get a 0 remainder, so the result is 2x plus 2. So cool. The width is 2x plus 2. The quotient, 2x plus 2, apparently is the length as well. Length equals 2x plus 2. Yay, there's the answer. So when they say, draw the figure and label its dimensions, I will do, well, it's a square. I called it a rectangle. We call it length and width. Who cares? And it's a square. I guess. Boom, boom. I'll even do all those. All right, 2x plus 2 and 2x plus 2. All right, we did long division with it. Let's go with synthetic division as well. Now let's take a look at what the original expression was when it came to division. So here's the original expression. How do we do synthetic division? Remember, this thing needs to look like x minus k. Does it need to be a minus there? No. Does this need to be a 1x? Yes. So what do you got to do? You got to factor out a 2. You could say divide by 2, and you could because this divides by 2 as well. But let's work toward factorization first. This is 4x squared plus 8x plus 4 divided by 2 times the quantity x plus 1. So two things are going on here, right? And let's see, maybe instead of writing it as division, let's write it as a fraction. So divided by 2 times x plus 1. I want you to note that 2 is being divided as well as x plus 1. So you have one of two options. You can either divide the 2 first with all of these, or divide the x plus 1 first. If you divide the 2 first, then that reduces to 2x squared plus 4x plus 2 divided by x plus 1, and then use synthetic division on that. If you use x plus 1 first in your division, then you divide that first, and then you divide the 2 out after. So this could be a result of what you do, and then we use synthetic division on that. So negative 1 is your root, and then 2, 4, and 2, and then you go synthetic division on this thing like that. Remainder is 0, you get 2x plus 2 as that result, right? So we get the same answer, but it wouldn't happen if you put in negative 2 as this thing and just ignored it. This isn't the same thing as x minus 2, right? The root of this thing is negative 1. It always was. It always was negative 1. And here's the other issue that you can have here. Remember when I said that you set it equal to 0 and x is negative 1? Even be careful with that. This may be the root, but there's still a 2 that's part of the factorization, that's part of the product on the bottom. All right, that's where I would recommend using long division probably. I think I would even use long division unless I understood that you could factor out a 2 and stuff like that. All right, number 35. I don't know how much room's there. Let's keep going. Number 35. The total attendance A in thousands at NCAA women's basketball games and the number T of NCAA women's basketball teams over a period of time can be modeled by this and that. It's kind of a lot, if you don't mind me copying and pasting that one. Where X is in years and X is between 0 and 18 years. Okay. Not including 0 and 18. Write a function for the average attendance per team over this period of time. Oh, that's blue. So attendance is A. Number of teams is T. I guess the number of teams is growing over time or something like that. So you divide attendance by teams, right? Attendance by teams, and then you get a function thing for it. Now, I don't know if we're doing the slope aspect of that. X doesn't equal 0 and 18. They did say average attendance per team. I think we're just talking about the division aspect, doing a division of A divided by T equals this divided by this. Come up with a function. It's really just their question. Now, the decimals intimidate me. They intimidate me in such a way that I don't know. I just mentioned why synthetic division can't really be used in this scenario unless you factor out 14.8. But I don't know if 725 can divide by 14.8. Let's see. Divide by 14.8. No. So, when you look at this right here, it's kind of a number. So that can't be a good root to use. And then we divide by 14 after. I don't think synthetic division is going to be the way to go. Long division is going to be just as tricky as far as numbers we're going to have to use. What I want to do, I don't know what I want to do. I want to use long division, but we're going to have to write rounded numbers in our answers probably. I doubt 1.95, this is something we're going to have to do later, can divide by 14.8. Even that number stinks too. So, but at least that's it's a number we can round for our function. But we're going to have to do that, guys. We're going to have to do some form of division. Because we got to write a function for this. So I'll do negative, let's see, 14.8x plus 725. A lot of calculator use. This thing does say using tools. I'm guessing they're saying use the calculator. So negative 1.95x cubed plus 70.1x squared minus 188x plus 2150. Now let's do it. We got to figure out how many times 14.8x goes into negative 1.95x cubed. Now x goes into x cubed, x squared times. That's no problem. But how many times does this go into this? You do division. And I just did that number. I did it right here. I didn't write it negative. But 1.95 divided by 14.8 is 0.1317, etc. Now I'm going to write that as just 0.13, negative 0.13, negative 0.13x squared. So I'm going to write this here because this times this gives me that. Keep in mind there's an exact answer in play, and it's this number here. So I need to use that, multiplying it by 14.8. We will, right? That becomes negative 1.95. So this times rounded should give me this exactly, or you know what I mean? Those will cancel. But what I got to do is now do 725 times this number. That's where I want to use the number in my calculator for it. So this number, well, times negative 1. Actually, I don't know if I need to do that. But times 725 gives me negative 95.5. Negative 95.5. Sorry, I'm trying to write it on this other side. X squared. A lot of back and forth on the calculator here, y'all. And we're going to do a subtraction here. We got to do this minus this, which means this plus that, right? That's why I said I don't know if the subtraction is needed, but we do have to write it exactly like that there. So I got to do 70.1 minus that answer. And we have this number here. So 165.6, I'll try 0.6, x squared minus 188x plus 2150. Okay, so now we're here. So now I got to figure out how many times 14.8 goes to this number, the 165.6. Keep in mind, there's another number on the calculator for it. So I got to do this divided by this to figure it out. So on the calculator, 165.6 divided by 14.8 is this number, 11. Well, I used two decimals for this top one, so 11.19 plus 11.19x, right? X times x is x squared. So this times this is that, 165.6. 725 times that is this number. Ooh, that's big. Plus 8113.3. And we got to subtract that, well, x. So as this cancels here, I'm going to write this one probably a little more over. Numbers getting big. We got to do this number minus that answer. So negative 188 minus that. So negative, this problem's weird. Negative 188 minus this. And we get negative 8301.3x. And there's still the 2150. So I had to write this over here a little bit because I was running out of room. Boom. So now I got to figure out how many times 14.8 goes into that number. Once again, do another division. But we're writing out our model, right? Our function that models this scenario. Set over 0 to 18. I don't know if I do anything with that. I don't think we do. I think that's just your domain. They're just saying come up with a function. They're using the 0 to 18 to say this is where the function works well. Anyway, so this divided by 14.8 will be the last number in our thing before the remainder, I'm assuming there's a remainder. Negative 560.90. So minus 560.90, okay, is what I'm writing here. So that times that gives us that. I don't know if this would have been easier. This would have been easier than synthetic division because synthetic still required different kind of factors. It's weird. It wouldn't have been good. I got to do 725 times this, and then I got to subtract. I got to do 2150 minus that answer. So I'm going to stay on the calculator for that. So 725 times this answer. And then we'll do, 2150 minus that answer, which becomes a plus, becomes positive. So positive, this is our remainder. But hold on, negative. Okay, you see the numbers there. I'm going to write them down. So negative 406,652.5. Subtract them. And then now we have 408,802.53 as the remainder. So our final function will be this with this remainder. So I get copy, paste this guy. I'll write it in green. It's a staple of mine. And then with the remainder of this, we'll talk about how that works in a second. So this, boom. All right, so the answer for our function will be this plus that over 14.8x plus 725. So this is the function that models our stuff from 0 to 18 on x for your domain. Whew. I didn't like that problem. If the decimals were clean, I'd be fine with it, but that was a no. All right. Number 36. I think we have 5 more questions. Comparing methods. The profit P in millions of dollars for a DVD manufacturer can be modeled by P equals negative 6x cubed plus 72x. Let's write that. At least it's clean. Where x is the number in millions of DVDs produced. Use synthetic division to show the company yields a profit of $96 million in 2 million when 2 million DVDs are produced. Is there an easier method? Explain. Well, what we get to do here, remember, x is in millions, so you can plug in 2 for x and, be good with that. But so we're looking at, for this setup, where x equals 2. So we're going to use 2 as our root for synthetic division on this. We have a negative 6x cubed, no 0x squared, a 72x, and a 0 constant. My goal here is to do synthetic division on this and use the remainder as our value for millions of dollars of profit. So we're going to multiply, add, multiply, add, multiply, and right there is the 96. 96 is the number of millions of dollars. That verifies, use it to show that. That is the show, checks out. And there we have it. They said, is there an easier method? Explain. It depends on who you are and what you prefer here. We could have also substituted 2 for x. We could also substitute 2 for x and evaluate. So P of 2 is negative 6 times 2 cubed plus 72 times 2. So P of 2 2 cubed is 8. Negative 6 times 8 is negative 48. 72 times 2 is 144. Negative 48 plus 144 is indeed still 96. Is that easier? I'd say so. I think there was less work as an overall involved set. You still had to deal with bigger numbers that you had here. And you didn't have to set this up. You didn't have the placeholder issues that could come up, stuff like that. So you might ask, why would we use that other thing? Again, they're reasons that we're not really talking about here, but there are reasons. All right, number 37, critical thinking. What is the value of k such that this has a remainder of 0? So x cubed minus x squared plus kx, minus 30 divided by x minus 5. We want a remainder of 0. Let's use synthetic division on this. 5 would be your root if that's the case. If 5 is your root, we have 1, negative 1, k, and negative 30. The goal here is not to do guess and check. The goal here is to end up writing an expression for your remainder in terms of k, set that equal to 0, and solve for k with it. So follow me with this if you can. Synthetic division, we got 1 times 5 here. Negative 1 plus 5 is 4, times 5 is 20. Now k plus 20 is exactly that. It's k plus 20. This is the constant value. We actually don't care what the constant value is when it comes to the result. They didn't ask. They're talking about the remainder, and we need to use this expression times 5, which is 5k plus 20, or plus 100, by the way. We have to distribute the 5. And add it with this. Negative 30 adds with 100, and you get 5k plus 70. Now 5k plus 70, being the remainder, is the thing we need to be 0. We need the value of k that will give us 0 here. So if 5k plus 70 equals 0, 5k is negative 70. Therefore, k equals negative 14 divided by 5. That's the value of k that we want. Which means apparently that's what goes in here, right? X cubed minus x squared minus 14x minus 30. That would give you a constant here, apparently, of 6. You know, all that stuff would be involved. But that's the k value that you want, negative 14. And that's just a result of using synthetic division the way that it was presented, right? Kind of bringing that about and then going forth, if you will. Okay. What number was that? 37? Okay. 37. Now, oh, there was multiple choice. I didn't see that. There it is, negative 14. So, oh, you know what? I guess we could have plugged in numbers, but I won't want to check each one. I'd rather do the problem like that. I didn't know it was multiple choices we were doing it. So anyway, the answer is A. Okay, number 38. Number 38, how do you see it? The graph represents the polynomial function f of x equals x cubed plus 3x squared minus x minus 3. The expression f of x divided by x minus k has a remainder of negative 15. What is the value of k? So we have this expression. Oh, I'm sorry. We don't. It says how do you see it? We don't have to do any calculations. So this one here, f of x divided by x minus k. Remember, it's if I substitute k in for x, I would get this value for y. So where does y equal negative 15, and what's that value for x? Negative 15 looks to be right here. Right here's negative 10, negative 15. Looks like the x value was negative 4. That means the value of k is negative 4 in that scenario. Okay, when it has that remainder, that's the equivalent of that given the remainder theorem. I can substitute negative 4 for x in my equation, and apparently I would get negative 15 out. I'm not checking it, but you can try that. Plug in negative 4, see that you get negative 15. Part B, use the graph to compare the remainders of that function divided by x plus 3 and that function divided by x plus 1. Use the graph. So in the graph format, remember, this is with a k value of negative 3, and this is with a k value of negative 1. So with a k value of negative 3, we'd get 0. So if I write that, can I? All right. X cubed plus 3x squared minus x minus 3 divided by, should I say all that? Because my goal isn't to do the whole remainder. Let me just say f of negative 3 equals 0. Because remember, our goal is remainder. So the remainder of the first one is going to be 0, because where you can see it on the graph. The remainder of the second one, negative 1, is also 0. So f of negative 1 will also give you 0 with that. Remember, I didn't substitute negative 3, negative 1 in there. I could have. I'm looking at the graph to make use of what those ones are and what they're asking. How do you compare? How do they compare? They are the same. They are the same. Remainder. remainders. I don't know. All right, that's number 38. Two more questions. Number 39, mathematical connections. The volume V of the rectangular prism is given by this function. Boom. Find the expression for the missing dimension. Ooh, we have options, and I want to explore both of them. So on number 39, let's copy and paste the box. All right, you can tell me which one you most prefer when it comes to this as an overall. Here's your volume. I probably have a preference, but actually, I don't know which one I'd prefer. You'd have to understand both of them. Okay. Volume is length times width times height, right? So this thing equals this times that. If we divided these two out from there, then we would get this length, this way, whatever, I'll call it length, right? So what we have to do is we have to say length equals the volume divided by x plus 2 and x plus 4 when they're multiplied, right? X plus 2 times x plus 4. So you have two options here, or more, but the two preferred options here are synthetic division or long division. Now, if you use long division, I would most recommend you first multiply out x plus 2 with x plus 4. So L is going to equal this divided by, and you FOIL that out, you get x squared plus 6x plus 8, and then do long division on it. So in the long division format, we'll do 2x cubed plus 17x squared plus 46x plus 40 divided by x squared plus 6x plus 8. So x squared goes into 2x squared 2x times. You multiply these guys out. Okay, I think I prefer the alternative. And then plus here, this will be 12x squared and plus 16x. Subtract those. You get 5x squared plus 30x plus 40. Now we see how many times x squared plus 6x plus 8 goes into 5x squared. That's 5 times. And then multiply those out. You get 5x squared. This cleans up. 30x plus 40. You get a remainder of 0. So remainder of 0 means your length is 2x plus 5. So length equals 2x plus 5. There's the answer. And that's using long division. You want to do it in one fell swoop, right? It's best to multiply that out. That was a very quick thing to work out there. Long division wasn't super long. I guess that wasn't terrible. The alternative is synthetic division. Now, in synthetic division, let me copy paste this thing here because synthetic has a little trick to it. Remember, you can only do linear factors like these. That's fine. But you got to do one at a time. So for synthetic division, you have to do synthetic division twice. The nice thing is, I think you can pretty much go from one result to the other, meaning let's start with -2 here. If I do -2 as my root with 2, 17, 46, and 40, let's go fast on that one. That better have a 0 remainder, I think. I think it needs to have 0 remainder, otherwise something doesn't go right for you. So now your result is this quotient right here, the 2, 13, and 20. So let's use this result of -4 on these guys here of 2, 13, and 20. This is your quadratic linear constant. And now -4 synthetic division on this is 2, -20, 0. And then you got that 2x plus 5 right there for your length. Okay, so you have to do synthetic division twice, one and then the other with that. I don't know which one you prefer, but notice the quotient of one you use to then divide the other part from there. Now you could use long division and do long division divided by that, and then long division divided by that. I think that's going to take too long, especially with a huge setup. Just do that once with this one. Now, which did you prefer? I don't know. You can argue either way here. Long division had one fell swoop of this, but just wrote that. Synthetic was that. Probably a little cleaner, but you have to know what to do with it. Kind of your call. Either way, you get 2x plus 5 is that length. 2x plus 5, 2x plus 5, and we're good on 39. Last question is number 40. You divide two polynomials and obtain the result 5x squared minus 13x plus 47 minus 1 or 2 over x plus 2. What is the dividend? How did you find it? Remember, the dividend is the original numerator that was kind of on top, whatever. Actually, let me do this. I was copying it down, but let's separate that. All right, this is the result of dividing some function by x plus 2. You can see that x plus 2 is the guy that's there. So this divided by x plus 2 gave us that quotient, and that's that remainder. We want to find this. Find f of x. So what do? You multiply both sides by x plus 2. X plus 2 here and x plus 2 there, right? Boom, boom, they cancel out. But what happens over here is, and we saw this needs to multiply by x plus 2. So x plus 2 times 5x squared minus 13x plus 47. And then x plus 2 divided by x plus 2 cancels out here, so then you have minus 102. This is the very reason why when I plug negative 2 into here, that's the root, this wipes out, you get negative 102, and that's how that works. Now, I got to distribute this thing out. They want to know what the original function is, so I got to distribute here and here. Leave the negative 102 for the end, you know? So we got 5x cubed minus 13x squared plus 47x, and then plus 10x squared minus 26x plus 94 minus 102. All right, here's going to be our final function. 5x cubed stands alone. Negative 13x squared plus 10x squared is negative 3x squared. 47x minus 26x is something 21x. 21x, and 94 minus 102 is negative 8. So this must have been the original function that worked out to become that. If we want to double check it, let's double check it using synthetic division. Remember, x plus 2 was the thing we divided out. That means negative 2 is the root. So let's see if we get the same numbers of 5, negative 13, 47, and negative 102 with, whoopsie, I don't want to write negative 13 now, negative 3, 21, and negative 8. Let's see if, double check. Yes. So that pans out to be that. So this is indeed the correct answer. You can see how fast synthetic division did to verify that. All right, guys, that'll do it for this one. This is Mr. Robinson. Thanks so much for watching. Listen, the lecture was really the large portion of this. Everything else kind of came to be the way that it was. There was some exploration on some problems, but good to get it done. Next, we come up with factoring. So that's, I guess, if your remainder is 0, but we'll talk about factoring as a whole. That can either be very long or very short, depending on how I want to talk about teaching it. But guys, thank you. Take care. I'll see you in the next one.